Hello dear students, today we are going to discuss the topic that is capacitor in parallel. Capacitors in parallel. Okay, now just pay attention. What does it mean when the capacitors are in parallel? So, when the potential difference across the plates of the two or more than two capacitor are same, then we say that the above two capacitors are in parallel. Okay, now let us understand. To understand it better, first we will take an example of the battery. Which battery? The same battery which we see in our household, especially in torch. Okay, so suppose this is that battery. Okay, you will see that in batteries, this is that battery used in torch. Okay, something like that. Now, what does it mean? If you see the rating of the battery, it will be written that it is of 1.5 volt or something like that. What does it mean? It means that this is 1.5 volt. Okay, it means that the potential difference delta V between this positive terminal and negative terminal is 1.5 volt. Okay, this is the designation of the battery. Now, if for convenience, I am repeating, if for convenience, if we assume this one to be zero potential, so then this one will be 1.5 volt. Okay, zero potential, it implies 0 volt. Now, this concept has to be used when a battery is attached. This concept comes into play. Okay, now we will see. Suppose this is a capacitor. Okay, and this is connected to a battery. The symbol for battery is this one. Okay, now if C is the capacitance, so just now we saw that this is lower potential, that is 0 volt, the smaller one, and this is 1.5 volt. Okay, this is the circuit diagram for the battery showing the potential. So what does it mean? It means that this potential difference of 1.5 volt will appear across the plates of the capacitor, that is 1.5 volt. Okay, so since this is zero potential, this end will also have zero potential or 0 volt. Okay, and this end is having 1.5 volt, so this end will also have 1.5 volt. Okay, now here it is the single capacitor. Okay, now if we connect two capacitors in such a way that okay, now suppose this is one capacitor C1 and this is another capacitor C2, and when these two are connected here this way, and again this is connected to the battery, just now we saw. So if we go through this, what we will observe that if this is 0 potential and this is 1.5 potential, just a numerical figure I am giving to make you understand. If this is at 0 potential, this point will also be at 0 potential or 0 volt. Okay, and these 2 points, this point and this point, these two will also be at 0 volt. Now this end is 1.5 volt, so this end will also be at 1.5 volt, and this end and this end, they will also be at 1.5 volt. Now after understanding the potential distribution, if we see, then what we observe is that the potential difference across the plates of the capacitor, of the two capacitors C1 and C2, is same. Difference, potential difference. Okay, so now we can say that C1 and C2 are in parallel. Okay, so the potential difference across the two capacitors must be same. Now take another example. Suppose this is C1, this is C2, and this is C3. Now we connect it in this manner. Okay, and now we have not connected the battery, but after seeing this arrangement, we must conclude that these three are in parallel. Why? Because to understand, if we connect any battery, so whatever is the potential difference at this end will be the potential difference here, will be here, will be here, and will be here. Okay, and whatever is the potential difference across this end, the potential difference across this end, the same potential will be at this point, at this point, at this point, and at this point. So here again the capacitors are the capacitor C1 and C2 and C3 all are in parallel. Okay, now when we come to the parallel arrangement, we must consider few other things also. Just for example, so what happens if Q is the charge drawn from the battery, or it is flowing? Okay, just or drawn, you can understand, we will come to know later on in electric current chapter. Okay, if this is the charge Q, so here it is Q1, Q2 and Q3. So instead of here we can write Q total. So total charge is the drawn from the battery. Okay, so here it will be Q1, Q2 and Q3. Now in electrostatics we have studied charge is a conserved quantity. Charge is a conserved quantity. Okay, just like in the basic classes we have studied, energy is a conserved quantity. Energy can neither be created nor it can be destroyed. So what does it mean? Mathematically it means that Q total is equal to Q1 plus Q2 plus Q3. So it means that if we write Q total as C equivalent into V, let V with the potential difference of this battery into V, then we can write it as C1 into V plus C2 into V plus C3 into V. Okay, It means that we can write C equivalent is equal to C1 plus C2 plus C3. Okay, so this is important derivation from board exam point of view as well as from other competitive examination point of view. Now here one more thing you have to understand, what does this C equivalent physically mean? Physically it means that if instead of these three capacitors, suppose we are putting another capacitor, okay, let this be C equivalent. Okay, so instead of these three capacitors, if we put a C equivalent and connect it across the same potential difference, after removing this, so what we will get? We will get C equivalent into these V, and this will be the Q total. Okay, so this is the concept of capacitors in parallel. Now the other important point for any general arrangement, suppose this is C1, suppose this is a capacitor, say C1, C2, C3 and whatever it may be. So when we calculate C equivalent, so C equivalent will be summation of C, okay, I, where I goes from 1 to n. It means that when there is a parallel arrangement, in parallel arrangement of capacitor, in parallel arrangement of capacitor, the equivalent is found by summing all the capacitor, summing all the capacitor. Okay, now consider one more example, C1, C2 and C3. Now see, this is V. Now in this arrangement, this C1 and C2, they are parallel and its equivalent will be in series with C3. So if we write C equivalent and then this is C3, this is V. Okay, so this C1 and C2, they are in parallel and it is in series with C3. So these two will be in series. Okay, now this is all about the capacitors in parallel. Okay, so study well, and if you have any kind of confusion, you can call me on the number in the WhatsApp group. Okay, so that we can discuss whatever is there with respect to the video. Okay, thank you very much. Okay, so study well, and if you have any kind of confusion, you can call me on the number in the WhatsApp group. Okay, so that we can discuss whatever is there with respect to the video. Okay, thank you very much. The video. Okay, thank you very much.